Okay, hello everybody. My name is Claudia. I'm a teacher. My entire career so far has been in early years classrooms with children up to age 5. But in September, I'm going to be teaching in year 2 for the first time. So I thought I'd have a look at number bonds today, and specifically number bonds for children 3 to 7 years old. So that's in the early years, that's year 1 and year 2. So it's early years up to the end of Key Stage 1. So first of all, what are number bonds? A number bond is basically a way that you can make another specific number. So it's two numbers that you can add together, a pair of numbers which make another number. So number bonds to 10 are different pairs of numbers that you can add to make 10. And children learn number bonds at school because they're so useful for helping us do more difficult, more complex calculations later on. So 7 plus 3, 10. You probably knew that without even having to work it out. Grown-ups, we just know that 7 plus 3 is 10. It's a fact. It's a number fact that we know. We don't need to count. We don't need to, work it out at all. We just know that 7 plus 3 is 10. 7 plus 3 is a number bond, a way to make 10, and it's one of several ways that you can make 10. So let's see how knowing number bonds like 7 plus 3 can help children in their maths. Have a look at these two sums. So these are a little bit more complex. We've got some much bigger numbers and we've got some decimals. Now imagine trying to work out these sums without knowing that 7 plus 3 is 10. It would make things very difficult. So you can see how knowing that 7 plus 3 equals 10, along with a little bit of place value understanding, would help you solve these maths problems. Let's take another example, more of a real life example here. So imagine you're adding up two lots of money. So you've got £50 plus £20 equals £70. How do you know that? Because you know that 5 and 2 equals 7. £20 plus £10 is £30. Again, you know that because you know that 2 plus 1 equals 3. Put the two together, £70 plus £30. Knowing that 7 plus 3 is 10, that's one of our number bonds, means that we just know off the top of our heads 70 plus 30 equals 100. We don't need to count. We don't need to use a calculator. It's simple. It's quick. So why are number bonds important? Well, we said that children need to know number bonds to help them do more complicated calculations. But let's have a look a little bit more in depth here at how children's learning of number bonds and how they use them develops throughout Key Stage 1. So they start in foundation stage, sort of. They start to separate groups of objects, and then they hopefully will start to recognize that the total of two groups will stay the same. Even if you move objects from one group to another, the total is still going to stay the same. There's going to be lots of visualizations, hopefully lots of real objects that they can move to help them build this understanding of that. And then in year 1, children will be starting to use number bonds up to 20. So they'll be using their number bonds to do calculations, and they'll be starting to derive some subtraction facts as well, which they're going to use to help them. So they're going to memorize and use their number bonds to 10 and to 20 in several forms. We'll come back to that a bit later when it says in several forms. In year 2, kids are really confident with their number bonds up to 20, and they're going to be using them in combination with some place value understanding to solve much more complex problems. And they're going to be pretty fluent in deriving facts. Again, we're going to come back to that later. And they're going to be deriving and using facts up to 100. Finally, in year 3, children are very fluent with using their number facts and as well as their place value. And they're going to be solving problems using these understandings much more easily. Okay, so number bonds in the early years. So this is just a screenshot from the Development Matters document for the early years foundation stage curriculum. And you can see that this is from the maths number section. And these are just some aspects of what children are expected to usually be doing or learning to do at this age, 30 to 50 months. 30 to 50 months is 2.5 to 4 years old. But remember, every child is unique. So, this is just a guideline and, not to worry if children aren't quite doing this or if they're doing a bit more than this. So I've highlighted the one that says separates a group of 3 or 4 objects in different ways, beginning to recognize that the total is still the same, because that is the key. It's kind of like the foundational understanding that kids get in the early years, which leads them to using their number bonds later on. So they need to have that understanding that an amount or a number of objects or a group of objects can be split or broken down in different ways, and across the different ways, the total is still going to be the same. So hopefully they're going to be using lots of real world objects, manipulatives, counters, could be everyday objects as well, things like apples or, other fruits. It could be toys, books, anything that, they're interested in and helps them understand. So here you can see we've got 2 groups. We've got 2 and 3. 2 and 3 make 5. But even if we move 2 from that second group over to the first group, now we've got 4 and 1. The total is still 5. Okay, so next, children might start to look at some more sort of organized visualizations of breaking down numbers. So here you can see a part-whole model layout, and you can see that this represents 5 broken down into 2 groups. There we go, which is 2 and 3. So children can look at this and say that 2 and 3 makes 5. Now, what if we took away 1 from the first group and put it in the second group? 1 and 4 makes 5. Okay, so it's just another way of making it visual, making it really easy for children to understand. Next, they might look at a similar thing, but with maybe some objects missing, and they might be asked how many more will they need to make the whole at the top. So here it's 4. We've got 3 on one side. How many more do we need? We need 1 more to make 4. Okay, so what are the actual number bonds to 10? So the number bonds to 10 you can see listed here. These are the different ways that children can make 10. Obviously, these can be flipped around and they're just the same. So children should start, they might naturally even start to notice these number bonds and kind of start to memorize them themselves. But we also do lots of activities with them, which, like songs, chants, poems, little finger stories, things like that, which help them become more familiar with these number bonds in preparation for being able to use them in their maths. So 10 frames, this is a 10 frame. It's just a grid with 10 spaces, which children are introduced to, and then they must know that there are 10 spaces. So they'll know then that if all the spaces are full, how many objects do we have? We've got 10. So a 10 frame with 2 different types of objects on it. Again, it's full, so we know that we've got 10 altogether. And so this kind of thing I would have used in my classroom this past year to encourage children to kind of understand that these two groups have made 10. And so I'd probably ask, how many green dinosaurs do we have? 8. How many blue dinosaurs do we have? 2. And how many do we have altogether? 10. And then I might even encourage them to just tell the number story or say the number sentence aloud. A 10 frame with a few objects missing. So how many more do we need to make 10? So again, we've got 7. How many spaces are empty? 3 are empty. So that means we need 3 more to make 10. And 7 plus 3, that's one of our number bonds. All right, so number bonds in year 1. Now, the same 10 frame, but this time you'll notice that there's a number sentence at the bottom with a number missing. So kids in year 1 might be encouraged to finish the 10 frame and then finish the number sentence as well. So just add in the number there. All right, so number bonds to 10 we've looked at. Now here are the number bonds to 20. Obviously there's a lot more this time because we've got more numbers to make. There's more possible ways to do it. So again, kids are going to start getting familiar with these and start to be able to use these in their maths to solve problems. So in year 1, here's the part whole model layout again, but this time you'll notice that it's got numbers in, and children might be asked to complete this. So you can see the whole is 10, and then we've got a 5. So what is missing? How many more do we need to make 10? And, oh dear, that's wrong. Sorry about that. So that should say 5. 5 and 5 makes 10. And then on the other side, you can see we've got another 10 frame. Just a reminder that year 1's, and year 2's actually, everything should be very visual, pictorial, and it's all about representing their understanding visually. So aside from the 10 frames, sometimes kids will come across kind of like bars of blocks like this. So they might be 10 blocks long. So as you can see here, 4 of them are filled in. How many are missing to make 10? 6 more are needed to make 10. And so then they would just write the 6 in there to finish the number sentence. So now we're encouraging them to kind of show something pictorially and then write their number sentence underneath. All right, subtraction facts. So once kids have got their number bonds down and they know them all, they're really good with them, they understand how they're using them and everything, then they can start to derive or come up with subtraction facts. So all they need to do is move the 10 over to the other side, to the beginning, and then take away one of the other numbers, and the answer will be the other one that they didn't take away. All right, so it's the same numbers, 7, 3, and 10, just with a minus sign and obviously moved around. So that's how they derive subtraction facts. So again, here you can see some subtraction facts within 20. 6 plus 8 is 14. If they know that, then they also know that 14 take away 8 is 6, and 14 take away 6 is 8. All right, so number bonds in year 2. Now, since they've been able to start deriving some subtraction facts in year 1, they're going to be able to come up with complete fact families. So they're going to have their number bonds, not always to 10. So now they're going to be, it could be to another number. But once they have that initial one, they'll be able to move the numbers around to make other number facts. Could be addition facts, and then it could be subtraction facts as well, to make a fact family. So deriving related facts means that, so this was mentioned in the curriculum, that's why I've checked out what this means, because I wasn't sure either. Deriving related facts means that kids can basically come up with loads of other facts, or basically just number sentences based on one initial number fact that they knew. So you can see here, they knew that 3 plus 7 was 10, which meant that they knew that 10 take away 7 was 3, and 7 is 10 minus 3, or 10 minus 3 is 7. And because they knew those things, and they had a little bit of place value knowledge, they were able to know also that 30 plus 70 is 100, 100 minus 70 is 30, and 70 equals 100 minus 30, or 100 minus 30 equals 70. So you can see how just knowing those really basic number facts, like 3 plus 7 equals 10, it just grows from there, and all these other number facts come from there, and children start to notice these patterns and start to notice opportunities when they can use them. So this is just one more example of something kids might do in year 2. So you can see now we've got 2 10 frames, which means there's 20 spaces altogether. So kids would know that because they'd know that 10 and 10 is 20. We know the first 10 frame is full, so that must be 10. Then we've got 2 more orange counters in the second 10 frame. So that means we've got 12. And as you can see, there's a space, a missing number in our number sentence over here. And according to the picture, 12 plus, we can see 2 green counters, so 2 would go in there, equals 14. And then once children have done that, they'll be able to then derive a subtraction fact with the same numbers. So we've got 14, and then the other 2 numbers are missing. And so once they've completed the first number sentence, 12 plus 2 equals 14, they'd be able to then fill this in and put 14 take away 2 equals 12. Or 14 take away 12 equals 2. Either one. Okay, and then the last thing I just wanted to mention, which is a little bit off topic, but I think important, especially for parents who are doing maths with their kids at home, is the 100 square grid, or the number chart to 100. I just think, from what I've been reading to make this video, seems to be a really, really important resource just for kids to have available, not only for understanding where number facts come from, but place value. I mean, it's a great way for kids to see place value, and also noticing patterns in numbers. So, even if like counting in tens, for example, it's so easy for kids to see down the right hand side that they can count in tens and just go 10, 20, 30, 40, and that actually it's just like 1, 2, 3, 4, 5, but with a 0 added on. So I thought that was a really important thing, I think, for kids to have just as a resource at home. And I'm actually going to put that and a few other, like a 10 frame and a part whole model template. I'm just going to put them all together in some slides for you to download. It's up to you. If you want to, you can print them out and let kids, maybe you want to print them and photocopy them more times for kids to use at home. Maybe you want to keep them on the computer or iPad and, put your own counters in there, like what I've done in this PowerPoint, in this slideshow. Maybe make it fun and use dinosaurs or, unicorns, whatever kids are interested in. And just let them play about with that, and hopefully it will help. All right, thank you so much. And to read all about this on the blog, just follow the link below. Thanks, guys. See you next time.